Good morning, guys. Thank you for having me here today. My today's speech is entitled, "In the best teams, all engineers are architects, and why and how to get there." But before I will jump to this topic, first of all, I would like to talk a little bit about the software architecture and why it is so important. And let me picture this problem with this example. It's based on the real study of the real software and the real enterprise. And let me start it that way. If the life is the art of decision making, let's observe what is the impact of bad decision making and bad decisions on the software project. So what we have here on this diagram, what we have here on this diagram is a size of the development team that were involved on real software project in a real software company. And what we see here that the size of this development team increased for each subsequent software release. So we see that there is a huge improvement from very little size of the team up to over 1,000 people. So it looks like it's a big success for this company. After all, such big number of people must produce a lot of new functionalities that is really welcome by the customer. And in this case, for sure, customers are pretty happy. So cash flows, and everybody are quite happy. So we have a big success here. To answer that question, is it success or not, we need to take a look on a little bit more data. So the one more diagram which I would like to share with you is a product size in thousands of code lines. And what we see here on this diagram is that starting with the field release, the product size doesn't grow up any longer. And considering this big number of engineers that I hired to work on this product, there is no surprise that the cost per code line for this software product is skyrocketing. So, in my opinion, it's not success at all. It's a disaster, calamity. So, where we are right now in this case, I would say that as a result of choices that were made, or perhaps a result of taking right choices, the code structure of the software product is full of unattended dependencies between classes, modules, and this kind of clutter confuses developers. So I would say that confusing developer is never a good thing. Because in case if we confuse developers, then productivity goes down. Because it's hard to write a new code, it's easy to introduce regression in the existing code, it's hard to test the code, it's hard to cooperate on such bad code base between the teams, and sometimes even between the developers in a single team. You might ask why I'm so sure of that. Because, please take a look on this diagram on the right side. This diagram, this heart of darkness, presents the dependencies between the classes in the existing software, in the existing company, which name I will not share here. And yeah, this is nothing easy to work with. So the problem is all about that we are wasting the time. So as we're wasting the time, our company may fail behind the market competitions, and we may even lose the market and go out of business. But hold on. After all, there are so many new, fine, bright, new, shining tools that we can use. Something wrong? So there is a lot of of new bright, shiny things that will help us to recover such situation. After all, we have our agile. After all, we have our continuous integration, development, deployment environments. After all, we have our a lot of new things that shall help us to overcome the situation. Unfortunately, this is a trap. It will not work. Now, all these things will not help us much till we will solve the main problem, which is the software architecture in this case. Moreover, all these new things, all these new ideas, all this new approach will just have this impact that it will show us even brighter and even more where the problem is, which is some kind of benefit for us, because now not only developers will be able to see that we have a problem with the software structure, with our architecture, but also management will see this very clearly. People from CI, CD will see this. Better say, everybody will see this, where the problem is. And again, this is not my opinion. I would like to use this book. This book it was written by the guys from the HP. They faced the problem, like I mentioned before, with this terrible diagram here. And they try to do a lot of things by using Agile, by using continuous integration, development, deployment, and they were not able to recover till they went and fixed the software structure, the architecture of the code. So I was talking about the software architecture, but the question is, what is the software architecture? So let's try to use this definition. The software architecture is a set of important project-related decisions that shape software structure in the way that software supports selected quality attributes and other properties. I will talk about these quality attributes in a minute, what they are. And all these decisions shall reduce the number of people needed to create and maintain the software system. So I can bet that most of you is surprised with this kind of definition of the software architecture. Most of us thinks about functionality in terms of software architecture. It is an important thing to say that functionality has limited impact on the software architecture and vice versa. Architecture has limited impact on the functionality. So why? Let me give you an example. Let's imagine that we have a software that is shaped like a big ball of mud, that big spaghetti code. It still is able to do the job as required, but the question is it easy to scale? Is it easy to maintain? Is it easy to port to some other hardware or whatever? So these are all things, these abilities, which we shall concern first. And let me jump now to the quality attribute, what they are. I mentioned before quality attributes. Let me say it that way. If the functional requirements describe what the software does, the quality attributes describe how good software does that. For example, performance is a quality attribute that describe how good software does things. But there are others: reliability, security, scalability, availability, many other abilities. I just put here a few of them, but there is more of them. It's an important thing to say that this quality attributes doesn't exist in the vacuum. They always exist within a context of scenario. What is the scenario for the quality attribute? It's a quality attribute specific requirement. Usually it's built with the 6 parts. First of all, we have the artifact, which is our software or part of our software system, which exists in some kind of environment. And of course, there must be some stimulus and stimulus source. And where is stimulus, there must be response. And then, if we have a response, then we need to have a measure of this response to know if we are good or not good. So let's take a look on example for quality attribute responsiveness. So in this case, let's imagine that our software under the evaluation is the web server, which exists with some environment, for example, medium server load. So in this case, the stimulus source and stimulus itself is web browser, which requests web page. And of course, response is a web page, which has a measure. This response has a measure, which is a time under the web page is generated by the web server. How to discover these quality attributes? First of all, we need to understand the business we are working for, technology we are using, and user expectations. Then we can iterate through use cases we have in our software, and then we can find the scenarios related to this use cases that will bring us to the quality attribute. So, but this, what I said, implies one thing. We need to learn. Generally, it's quite funny sentence, which I really like, that software development is a learning process. Working code is just a side effect. So, usually, as developers, we tend to be focused on technology, but to be able to talk about the quality attributes and architecture, we need to know at least a little bit a business we are working for. And also, how the people will use our software. Then, of course, we'll be able to come up with the ideas about our quality attributes. So there is a little bit a sweet spot of the knowledge and skills for the architect or someone who has aspiration to be an architect. The question is if there are any others factors that impact the software architecture. And yes, there are. Of course, I mentioned the quality attributes and some other constraints which are given usually by some business goals. For example, I may have some limit on the budget I will spend on this software solution. I mentioned before that functionality has a limited impact on the software architecture, but I didn't say that it has none impact on the software architecture. And yes, there will be some functional requirements that will have impact on the software architecture. For example, let's imagine that my software solution will need to hold or store some big amount of data. Then, of course, I may think about building in my software architecture some kind of database engine. So far we talk about that architecture involves making decisions about software structure concerning quality attributes, architecturally significant requirements, architectural rules, other constraints. It's important thing to underscore that these decisions mostly are trade-offs. And when we're talking about the trade-offs, we need to think about one thing. We shall always document our decisions, especially why we make such decisions, because why is more important than how. Let me explain. As I mentioned, mostly our decisions about the architecture will be a trade-off, so no one be happy about that. And later someone may came to our project, someone who doesn't know why, and may see this decision as improper, not correct, and may tend to change these decisions. So without knowing why we make such kind of trade-offs and trying to invalidate these trade-offs, these people may get into troubles with their code. On the other hand, maybe in the future, the reasons why we make some trade-offs will be no more relevant. So we will have an open way to change our decisions and maybe do some changes in our code, do some refactors, make some improvements. So I talked about software structure a lot, that architecture is everything that impacts the software structure, but the question is how to select the proper software structure. Is there any help for us to select right structure for our software? And yes, there is a help, and this help is named architectural patterns. What are the architectural patterns? Let me jump to the definition. An architectural pattern is a general reusable solution to commonly occurring problem in software architecture with given context. So that's the definition. But what they are, in fact, they are slightly like design patterns, which I think most of us or all of us know. But they have a little bit wider scope. And as business and technology are changing, then new architectural patterns emerge. And I would say that developers shall be familiar with at least few of them, and I'm pretty sure that you are familiar at least with the one, which is, for example, layered architectural pattern. So the next question is, if we shall be familiar, where we can find this architectural patterns. And I would say that every single book related to the software architecture will have a list of architectural patterns. I just put here a few examples which are free to buy in different languages, English, Polish, whatever you want. And all these books have a list of architectural patterns with cons and pros. So the next question is, which one architectural pattern to choose? And I suggest to use a very simple way, which is called decision matrix. And what we do, we just gather all quality attributes we mentioned before with the scenarios. We take all requirements, functional requirements that have an impact on the software architecture. We take some other constraints, and then we evaluate all suspected architectural patterns one by one, trying to determine if a pattern supports our quality attribute with this scenario, or maybe not, maybe works against it, or maybe it's neutral. And of course, the pattern which gets most pluses, it's our winner. But wait, there is more. On top of the architectural patterns are also architectural tactics. What are the architectural tactics? Usually, we call that a design decision aimed at achieving specific quality attribute in the software system. And there's important thing to underscore. Architectural patterns are focused on the software structure only, while the tactics can be focused also on the structure, but on the behavior, on the way how the components in the system interact, how they are deployed, or sometimes even how we develop the software. Let's have some examples. Example of behavioral tactics, it may be using a caching to improve performance. Interaction tactics, for example, using the load balancing to distribute requests in more even way. We may also have deployment tactics. We may use, for example, redundancy. So redundancy is when we have two same components that do the same job. When one fails, then second continues. So let's dive deeper in these examples. Let's imagine that the quality attribute I'm aiming for is availability. So the point is, device or system is working 24 hours per day, 7 days per week, all year long. So to get this availability, I may use some tactics which are grouped in 3 branches. What is a problem about this availability is that my biggest enemy in case of availability are the faults. So something is broken in the system. So it's obviously that I would like to detect faults in the system. Then perhaps I would like to recover faults and maybe prevent the faults. So I have here a number of architectural tactics which are gathered in 3 branches. So I will make a choice and I will choose from this menu of different choices, different options. I will choose 3 of them. So my selection is, I will use to build my system a redundancy, voting, and diagnostic. And here I have, using these 3 tactics, I'm kept up with the structure and behavior of my system, which is something that measures, I don't know, maybe temperature with using the sensors, and then it's doing some kind of control logic to control the actuator, which maybe is some motor, which speed up the fan, or maybe something else. The point is, using the redundancy, I'm capable with idea to have two sensors to measure the same value. Then I have two logic units which process very same program, and they using the voting tactics. I have the voter unit, and this voter unit controls the actuators, my motor or something else. Then I have used diagnostics, which see every single logic unit has a diagnostic unit that checks if logical unit is still operating correctly. And if not, then the voter is notified about that there is something wrong with the logical unit. And as you see, as I have two sensors, two logical units, the fault in one place, for example, broken logic unit or broken one sensor, doesn't stop my system to work. So that's how I use the architectural tactics to build the structure and behavior of my system that provides me availability. So it's important thing to underscore that this kind of evaluation with use different architectural patterns, different architectural tactics, and selecting the right architectural pattern and tactics is just the beginning of my job, because this kind of evaluation, which is ongoing process, it shall be repeated. We shall not do this only one time, but we shall repeat it. Why? Because architecture without regular checks will deteriorate and will be broken after some time. Moreover, maybe something will change about our requirements, I mean about our functional requirements and also quality attributes, so we will need to have changed our architecture. Of course, there are some formal way of doing the architectural evaluation, very heavy and complicated, but even the simplest evaluation is a benefit for us, and the simplest evaluation is just like that. Take your quality attributes and scenarios, take your requirements, functional requirements that impact the software architecture, take your current architecture in the state as it is. Maybe it's just UML diagrams on this point, maybe it's a code, and do evaluation against all these quality attributes and functional requirements, and you will end up with the list of improvements, which is directly your refactoring backlog. And that's quite important, because in many cases we developers are not pretty happy with the software, with the source code we have, and we think that there is room to improve it. But usually management is not eager to go for that. But having this kind of process, we're talking in the language that is acceptable for management. Having this kind of list of improvements, because we are giving information what will be better, what is improvement if we do this refactor works that we found out with this evaluation process. So at this moment, if we did this evaluation, we have this structure, we have this tactics, we know what to do, we may jump to code. Maybe not. I suggest that before we will jump to code, we shall model our architecture first. To what we would like to do this, because it will help us to establish common wording, share intentions between the team members and between the teams, manage complexity by encapsulating or exposing details with different views. And of course, we will be able to split big problem into small problems. And generally, you know, guys, the best way to deal with the big problems is just to chop it, split it to a small one, and then ignore all the small one. So, guys, and most important thing is that modeling will help us conclude the quality attributes if they are still supported or not. And frankly speaking, there are no excuses to do not model your software, because all tools you will need are for free, or at least basic modeling tools are for free. You can use Plant UML, of course, everybody knows UML, Plant UML with graphics. The point is, you just write with a special code, and then this code is transformed to the diagrams with the Plant UML and graphics. So you can keep this code with the text files together with your source code. And of course, everybody knows UML. If someone doesn't know UML, I recommend this one book. It's just UML 2.0. I know there's much higher version of UML, but believe me, UML 2.0 is good enough for most of us. The question at this moment is, we decide to do this architectural works. The question is how much and when. So let's see what will happen if we will do too less or too much architectural works. So this diagram is based on the real data, again taken from the real companies and composed into such diagram. And what we see, if we do very little architectural works, about 5% of project time, then we made up with doing up to 40% of reworks, bug fixes. So the obvious suggestion in this case is let's do a lot of architectural works. Yeah, up to 50% of our project time. Then, of course, we will spend very little bit of project time, about 5% to doing the reworks, fixes, refactors, whatever. Unfortunately, the point is that this huge amount of work put in the architectural things will be not balanced by the savings from the not doing reworks and refactors and fixes. So there must be some middle ground, some sweet spot between. And yes, there is. I just put here this sweet spot around 20% to 0% of project time which is spent on doing the architectural works. The question is if it is always true or not. And again, the answer is depends. So the sweet spot may move from the 5% of the project time we spent on the architectural works for small projects, up to even 40% for the large projects. So we know how much. The question is right now where to start. I suggest here a risk-driven approach. So what we do, we just analyze requirements, constraints, and quality attributes using a pattern. State might have consequences. Let me show you an example. Let's say that the DBase contains sensitive information about the customers. This is our state. The consequences may be a data breach may leak sensitive information. And this is the risk of the stakeholder, for the customer, to the user. So what we do, we generate this kind of risks, and then we prioritize these risks. And if we have a risk, we shall consider a technique to reduce this risk. What does it mean? So what are these techniques to mitigate the risk? We may apply in design, architectural pattern, or architectural tactic. We can do some modeling, some prototyping. We can do some formal analysis, security analysis in case of security issues, for example. We can do some risk storming and many other things. The point is, we shall do this as long as the all risks which are related to the architecture are lesser than any other risk, for example, some formalities. So in this case, for example, in this point, my biggest risk in the project is, for example, do I have a budget? Do I have a team to do this project? Not anything related to my software architecture. And then when I'm past this point, everything what I do as the architect, I just make sure that any new risk related to the software architecture doesn't spike up over these, let's say, other kind of risks. So now, finally, we can jump to the main topic. In the best team, all engineers are architects, and how to get there. So first of all, I would like to share with you a story about two architects, about two archetypes of architects. First one, we name him or she ivory tower architect. Guy who lives up high in his ivory tower in complete isolation. In very idealistic world, so everything what this guy creates is very idealistic. It's based on ideal scenarios, doesn't concern any implementation details. Any kind of real world constraints and complexness. Of course, as this guy lives high in the tower, he doesn't hear anything from the bottoms, so he is lacking of the feedback. And generally, everything what is happening is a top-down approach, so things are going from the ivory tower down to these poor developers. This kind of approach has problems because very often there is too little guidance given by the architect, so the team need to put additional effort to iron out these details. So in fact, team is wasting time to negotiating all these architectural compromises, decisions, and in fact, team is losing productivity. So as we right now learn about one of these architectural archetypes, let's see on the second one. The second one is named control maniac. What this kind of architect does, he micromanages team, enforces strict guidelines, focuses on consistency, prioritizes quality, and all decision making is centralized. What kind of issues we may have with this kind of approach from the architect? I would say that there is too many restrictions which suppress the creativity from the team, from the development team. And as you all know, developers are creative people who like to leave their mark. So this kind of approach may frustrate developers. And now the question is, if any of these two behaviors is good, or maybe one is better and second is worse, so which one is correct, which one is not correct? None of them is correct. I think you guess that none of them is correct. But to your surprise, everything what is between is fine, is okay. So the next question is, what is the right balance? And there is no good answer for that. It depends. It depends on the project size, on the timeline, on the skills and knowledge of the team. So if you would like to learn more how to behave and when, please take a look on this book here. There is more information how to balance the role. By the way, I just asked the Copilot to create this picture of two architects that are balancing their roles on the teeter-totter, but I didn't ask artificial intelligence to put the bugs in their hand. And so it's quite scary, you know, that artificial intelligence grow up the sense of humor. That's another thing. So let's do some changes in the way how we work with the architects. In a very traditional division of roles, we have this separate role for architect, which concerns quality, attribute, architectural patterns, component structure, rules, etc., etc. And then we have separate roles for developers that thinks about classes, relations, source code, tools, etc., etc. And there is a wall between them. So this situation looks like this ivory tower I mentioned before. So the point is just to tear down this wall and make sure that architects is a part of the team. So it's important that right now the architect is a part of the team, and And yes, of course, the architect can still be the part of some architectural team. So the architects, which usually is more than one, they can still have their meetings, they still can work out some general ideas that will be spread around many teams. But the architect is a part of the team. And the point is, there are daily interactions between the architect and the team. So the development follows the architecture, but also architecture reacts in the feedback to the development. So there is no ivory tower anymore. And there is a challenge for architect in this case. And this is a serious challenge for architect, because right now the architect is in position that he or she mentors the team. And mentoring, of course, is not doing a micromanagement. So what we're doing that, because we would like that team members are slowly stepping into the role of architect, at least partially. How we may do this? We might just start with doing the design in pairs, for example. We know how to do the coding in pairs, so why not to do design in pairs? Architect may create skeleton, some template for the new components, so the developers will know how to create a new part of code in the right way. Architect might define some expectations and guidelines, might define checklists. And now, interesting thing, because many of these ideas, checklists and guidelines, etc., may be formalized in some way that we may automate this checklist or whatever, or we may do some checkers or other tools that will check if the new code created follows the guidelines and expectations. And that's the idea which is a backbone of the evolutionary architectures, that we have checkers and other tools, for example, in our CI/CD environment, that make sure that the code which doesn't meet the expectation is not delivered to the code base. So finally, the point is that we delegate the responsibility down the ladder to speed up decision making, because that's the point, to do things faster. But there is a challenge for developers too, because the point is that developers and architects might a little bit different priorities. In case of developers, they need to know everything about something. Developers need to know about the code base, about the tools to do their daily job. And they need to have a deep knowledge of that. In case of architects, it's sometimes better to know something about many other things, to be aware that there are other choices. And even it's not necessarily needed to be very well, to have a deep knowledge about these other things, because you can learn as you go, but you have some kind of ideas about the different choices, so you don't do things the same way time after time. But how to do this? How to have this ability to know that there are other choices? I think we need to just learn. So I suggest to follow this kind of learning model that we are using in Rockwell Automation, which is named 70-20-10. And the point is, that's about the percentage of the time we spend on doing something. So we spend 10% of our time on doing some formal education, reading books, taking courses, taking a part in conference like this one today. Then we spend 20% of our time on mentoring with more experienced engineers. That's why I say that architect shall be a part of the team, so this mentoring works. And then, of course, 70% time we spend on learning by doing, so we applying all this knowledge we learn from this formal method of reading, of learning from the books, from the courses, and from the mentoring to our daily work. And why we would like to do this? Because we would like to have, as engineers, our toolbox full of different tools. Not just, to have a hammer only. Because if you are the guy who have the hammer as only tool in its toolbox, then every problem you see will seems to be a nail for you, and we don't want to be someone like that. So guys, that's all from my side. I hope that you enjoyed. If you have any questions, we still have a minute. Thank you.